All right, boys and girls, welcome back to the drive-through. As always, sponsored to you by the deli. Hungry? Stop by the deli. Make yourself a sandwich. Maybe a salami, peppered turkey, and ham sandwich with Havarti cheese on white bread with Dijon mustard. We're here today to talk to you about part 1 of 10.3. 10.3 is all about the dot product. The dot product is a vector operation that is going to be very useful in class. One of the most important things for you to remember, because you're going to screw it up, is that the dot product takes two vectors, but the result is a scalar. It's just a number. And we need to get good at interpreting what that number means. Let's start, though, by showing you how to calculate the dot product. So, if you have a vector v, that's x1, y1, z1, and we have a vector u, which is x2, y2, z2. Okay? The dot product, v dot u, is the sum of the products of each component. So it's x1 times x2 plus y1 times y2 plus z1 times z2. Okay? Notice this result, according to Please Excuse My Dear Aunt Sally, is a scalar. It's a number. So we take two vectors and we result it in a number. For the record, if we are talking about two-space, you do it the same way. Okay, same way. We just don't have any z's involved. For the remainder of this explanation of this introductory unit, we are just going to stick to two-space because it's easier for you guys to visualize. But I want you to understand, we might be talking in 3 dimensions, but anytime we're talking about the intersection of two vectors, whether we are talking about 3 dimensions or 2 dimensions, these two vectors lie in the same plane. And so it is always going to be a 2-dimensional representation or a plane representation, even though that plane could exist anywhere within our 3 dimensions. So keep that in mind. I don't want you to be alarmed that we're using two-space, because everything we do is going to be applicable. So let's take a look at 3 different examples. I've already widmapoi. Okay, we've got a red set of vectors, a blue set of vectors, and a black set of vectors. Let's just see what the results give us. So here we have 15, 3 times 5, plus 10, 5 times 2, and so the result is 25. The dot product of our red vectors is 25. Okay? Here we have negative 20, negative 4 times 5, plus 0, which equals negative 20. Okay? And here we have 0, 0 times 5, plus 0, 5 times 0, which is 0. So you can see that vector operations are, sorry, I had a visitor at the door and I totally lost my place. Remix. All right, here we go. When we dot product two vectors, we get a number. This number is positive. This number is negative. This number is 0. That's going to be the first important lesson about dot products. What these are is a compatibility factor, okay? And if you can see these red vectors here, they are both traveling in very similar very similar orientations or directions. Sorry, their directions line up. Not completely line up, but they line up. And that means that the angle between them is acute. So if the dot product is positive, the angle between the vectors is acute. Here, these blue vectors, they are not aligned. Okay? This first vector here is traveling to the right strictly, and this vector here is traveling up and to the left. So notice that they are not compatible. Okay? They're going in opposite directions in life. And that gives us a negative dot product. Now here, these two vectors are orthogonal or perpendicular. Okay? They have nothing in common. These two vectors actually are so opposite that they have negative aspects in common, meaning maybe they're traveling in such opposite directions that they might actually get along. These two vectors seem to really get along well, and these two vectors have literally nothing in common. So it's a good little exercise to get yourself introduced to what you're going to learn. Okay, now finally, the geometric interpretation of the dot product. We've got a vector u here, which I've called 5, 0, and we have a vector v here, which I've called 4, 4. You should be able to look at that, and from your wonderful, rich math backgrounds, you should be able to understand. That's a 45-degree angle. Okay? So, now let's see what u dot v is. You should expect that this result is positive. 4 times 5 is 20. 4 times 0 is 0. The dot product is 20. Okay? Now, I want to explain this to you. The angle between, right now, all we know is that if the dot product is positive, the angle is acute. If the dot product is negative, the angle is obtuse. And if the dot product is 0, the angle is right. Well, using the magnitude of the vectors, we can learn even more about that. So the magnitude of u there is 5. The magnitude of v, let's see, that's going to be the square root of 16 squared, 4 squared plus 4 squared. So that's going to be 4 radical 2. Okay, now, check this out. If we were to take the dot product and divide it by the magnitude of u times the magnitude of v, let's just see what that would be. Okay, so u dot v over the magnitude of u times the magnitude of v is 20 over magnitude of u. 5 times 4 radical 2. Well, let's look what that is. 20 over 20 radical 2, which is radical 2 over 2. Now, hold on a sec. That cannot be a coincidence. So let's look at a different set of vectors. I recognize this. I recognize that number, and it just cannot be a coincidence that it's radical 2 over 2. Okay, so let's see. What would happen if we took a vector, let's say, again, it was 5, 0, but this time we made this one, let's see, let's make this a 30-degree angle. So that would make, this is 5, this would be 5 divided by radical 3, and this would be 10 divided by radical 3. Okay, so let's call this vector right here, this blue vector, let's call it 5, 5 radical 3. Okay? Now let's take the dot product. So we'll call this U, we'll call that V, U dot V. 5 times 5 is 25 plus 0. So U dot V is 25. Magnitude of U is 5. Magnitude of V, square root of 25 plus 75, so that's radical 100, so that's 10. And we just found out that U dot V over magnitude of U times magnitude of V is equal to 25 over 50, which is 1/2. And that leads me to my final aspect of today's introductory lesson, and this is pretty good stuff. The angle theta between any two vectors can be found by using the cosine of theta is equal to U dot V over magnitude of U times magnitude of V. And I'm going to save that proof for someone that wants to get some extra credit in this class and make a video out of it. That's the end of today's lecture. That's more than enough information to get you started on Friday's homework. Boom!